So this is example number 10, right? Part A? Okay. So example 10, part A. Now, I told you guys to draw a free body diagram to get started, right? Emma, did you draw one for the train? You draw a free body diagram for the train? No? Yeah, what's that on the train? For the branch? Okay. The branch isn't really going to help us that much. But what's actually on the branch, though?
Gravity.
Gravity, the train, and the tree, right?
Yeah.
Okay. Let's talk about the train. What forces are acting on the train? Anybody know?
Gravity.
Gravity. Which way is gravity pull, Julian?
Down.
Down. So force of gravity pulls down. What else?
There's the boat.
There's the boat.
Bulb.
Bulb. Okay, I was like, there's a boat in the problem? I got confused.
No.
Okay. Now, the force of the bulb pulls which way, Derek? Down. Now, is the force of the bulb going to be bigger or smaller than the force of gravity? You guys had to guess. Smaller. Why smaller, Derek? Good. Smaller mass. Right? The bulb has a smaller mass. The bulb is 0.15. The train is 0.35, right? What else is acting on the train?
Gravity.
Tension. Which way is tension pull? Up. Now this tension is in the hook, right? Okay. How does that tension compare to these two? It's equal, so mine should really be a lot longer, shouldn't it? Okay. So we'll call this force tension in the hook. Okay, it could also be from the tree. How is force tension related to force gravity and force bulb? Good. Because we are not accelerating, right? If we are accelerating, we have to include that mass and acceleration here. Because this is the result of Newton's second law, F equals ma, right? A is 0, so F net works out. Okay. Would anyone want to see me start with F equals ma?
Oh, yeah.
Yeah? Okay. So, we really start with F net equals ma, right? What's the acceleration in this case? 0. Hopefully, if it's not 0, then we're going to lose some ornaments here. Okay? But is the combination accelerating in any direction? Is the train accelerating? No. Okay? So, we have the force tension. Guys, force tension minus force bulb, right? Minus force gravity equals mass times acceleration. Okay? And you said, isn't 9.8? Yes, the acceleration due to gravity is 9.8, which is in that force gravity component. But the overall acceleration of the system is? It's not accelerating, right? So this overall acceleration is 0. So that means this side is 0. Add force bulb and force gravity both sides, and you arrive at this.
Rich, did I mention that I wasn't here Thursday or Friday?
Well, that explains why I wanted to see it. Okay. Does that make sense, though?
Yeah.
Okay. Any questions, guys? Okay. Now, what forces are acting on the train? Or not the train, the bulb. Gravity, good. I think you guys knew what that meant. We have gravity pulling down. What else? The train pulls up. Now, what is my third law pair here? Okay, good. This force down from the bulb and this force up from the train are equal. Right? Does that make sense? Yeah. So I could do a similar Newton's second law problem here. F net equals ma. Force from the train minus force gravity equals mass times acceleration. What's the acceleration in this case? 0. Right? So this side is 0. We know force train equals the force gravity. And this is the force gravity on what? The bulb or the train? The bulb. Right? Put that in parentheses behind it. This is the force gravity on what? The bulb or the train? The train. Does that make sense, guys? Yeah? So could we plug in values now to see if either of our hooks will bend? Okay. Because this force train, right? That's in the hook above the bulb, right? Right? this force tension, that's the force in the hook above the branch. Now, which one do you guys think is most likely to bend?
No.
The one holding the train, because it has both forces in it, right? Okay. So I'm going to do the bulb and the train independently, and I'm going to show you a way that we could do them together, using what you guys just told me right there. That you guys think the train is the one that's most likely to bend. Okay. So let's do these independently and see, and then we'll go back and look at how we can do it all in one step versus three. Okay. So what's the force in this hook right here? Yep. The force in this hook right here. The second hook, hold up the ball. 0.15 times 9.8, right? Because FG is really mg, right? 0.15 times 9.8 is how much? 1.47. So, will the force in this hook, will that force cause the hook to bend? No, because that force is less than 5 newtons. Because it said the hooks can hold a maximum force of 5 newtons.
How much is that?
How much is that in what?
Weight.
What do you mean by in weight? That is a weight.
What?
Newtons are a force of gravity. It's a weight.
So.
You want pounds, right?
Yeah.
Okay. In pounds, you have to divide that by 2.2. Okay, that's how many pounds it is. Okay. So like 5 pounds or 5 newtons is like 2 pounds. A little more than 2 pounds. Alright, so does that make sense, guys? Okay. Now for the train, a lot of students when I ask this problem will just do 9.8 times 0.35 because that student didn't draw the free body diagram. Okay? They're just thinking, well, the train has a mass of 3.5 or 0.35, so we'll just multiply that by 9.8 and see what we get. Okay? Will that work? No. No. Because we have to add the 0.15 because the bulb is also pulling down on the train. So the train's hook is supporting both the bulb and the train, right? And that's why we have this equation right here. Okay. So the force from the bulb, we said these were third law pairs. We found this down here to be 1.47, right? So the force tension is 1.47 plus the gravity acting on the train, right? Right? Gravity is still mg, so the mass is 0.35 times 9.8. What's 0.35 times 9.8? What is it? Thank you, Kira. So you have 1.47 plus 3.43. So will the hook hold? Yeah, how do you know? I mean, are we what? 4.9? So yes, the hook will hold because the maximum is 4.9. Does that make sense? Okay. Now, I told you there's a way we can do this in one step. You guys said that the train hook was the more likely one to bend, right? So this hook right here, what does that see? If it had eyes, would it think it's holding 0.35 kilograms or 0.5 kilograms?
Only 4.5.
0.5, right? Because it's holding 3.5 and 1.5. So it's like this is how big of a mass? It's like we have a 0.5 kilogram mass. Okay, does that make sense? So we could think of it this way as just 1.5 kilogram mass being supported by that top hook, or that top string. Does that make sense, guys? So then our free body diagram would be force tension up, force gravity down. This force gravity is going to be 0.5 times 9.8. Does that make sense? Does that make sense? Okay. So Newton's second law tells me, is this 0.5 kilogram mass is it accelerating? No. So Newton's second law says F net equals MA. MA is 0. I drew that. I'm terrible. MA. MA is 0 because we're not accelerating, right? So then we know the force tension minus force gravity equals 0. Force tension equals force gravity. Force tension equals 0.5 times 9.8, which is 4.9. So this right here is equivalent to what we did over there. And since this hook will hold, do you guys think the bottom hook will hold?
Yes.
They both should. Does that make sense, guys? Guys, does that make sense? Yeah. Yeah, are there any questions? No?